Good morning everyone. I am Tanushree Dalai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper which name is Structural Design 2. So in the last class we discussed a numerical based on unequal angle section. So now we will start from the beta calculation. So for the beta calculation, we need to put the value of BS, LC and omega. So the omega value is 75 mm, BS value is 127 mm and LC value is 150 mm. So we calculated all these things in the previous class. So now put all these value in the beta formula by which we got the value of beta as 1.032. So your beta is always greater than 0.7 and less than Fu gamma m0 divided by Fy gamma ml. So this is the criteria for calculation of beta. So here the beta is fully satisfied with this condition. So we can take the beta value as 1.032. So now we can calculate the strength in rupture. So now TDN equal to 0.9 ANCFU divided by gamma ml plus beta AGOFY divided by gamma MO. So by putting this value 0.9 into ANC is 0608, FU is 410 divided by 1.25 plus beta which is 1.032 into AGO is 568 multiplied by Fy which is 250 whole divided by gamma m0 which is 1.1. So by calculating this we got the value of TDN as 321.70 kilonewton. Hence the strength of the unequal angle section in rupture is equal to 321.70 kilonewton. So now comes to the calculation of strength of block shear of the angle section. So now you can see in this figure the connected leg portion is considered as a single flat section, and here the 4 numbers of bolts are provided in one row. Hence the block shear should be in this direction and again vertically in this direction. So this portion is considered as the block shear portion for the ISA. So this portion is maximized here. So now for the calculation of the area of V line and T line, we need to consider the horizontal portion as V line and the vertical portion as T line. So along the V line we need to calculate AVG and AVN, and along the T line we will calculate ATG and ATN. So first of all AVG, which is cross section area of the block shear along the V line. So the formula is the width of the block shear along the V line multiplied by thickness of the block shear portion. So the total width of the plate of block shear along the V line is from here to here. That means 40 plus 50 plus 50 plus 50 plus 40, which is the total width of the block shear portion along V line, multiplied by thickness, which is given as 8. So by calculating this, we got the value of AVG as 1520 mm square. Next one is your AVN. So as I said in before, to calculate the AVN, we just need to deduct the bolt hole portion from the total width of the block shear along the V line. So along the V line, in one portion, that means along the top portion, the block shear bolted are provided. So the numbers of bolts are here 1, again 1, again 1, and it is half of the half. So we will take this as 1 by 2. So the total number of bolt is 3.5. So by multiplying 3.5 with the diameter of the bolt hole and deduct this from the total width of the block shear along the V line and multiplied with the thickness of the angle section, we can find out the value of AVN. So by calculating this, we got the value 960 mm square, which is the value of AVN. In this way, the ATG and ATN value we can calculate. So to calculate the ATG, which is the cross section area along the T line, that means the width of the block shear along the T line multiplied by thickness of the block shear, which is 8, and the width of the block shear along the T line is here to this much, which is 40, here to this much. So the formula is 40 into 8. So here we got the value of ATG as 320 mm square. And last one is your ATN, as similar to AVN. So here we need to deduct the bolt hole area portion from the T line. So you can see along the T line, only this portion is we have to deduct. So this portion, that means the numbers of bolt hole here is 1 by 2. So 1 by 2 multiplied by the hole diameter, which is 20. So we can deduct this portion from the total width of the block shear portion along the T line. Hence, we got the value as 248 mm square. Hence, we can find out the block shear portion, that is the TDB1 and TDB2 from these 4 kinds of area. So just put the value like 1520 into 250 divided by root 3 into 1.1 plus 0.9 into 248 into 410 divided by 1.25. Hence the value is coming as 272.66 kilonewton, which is the value of TDB1. So now put the value of ATG and AVN in the TDB2, by which we can write 320 into 250 divided by 1.1 plus 0.9 into 960 into 410 divided by root 3 into 1.25. Hence, the value is coming as 236.343 kilonewton, which is the value of TDB2. So now we know that the strength of the block shear of any tension member is the minimum of TDB1 and TDB2. So hence the minimum value is 236.343 kilonewton. So now the strength of the total angle section is equal to the minimum strength of the yielding, rupture and block shear. Hence, the minimum value of the strength is coming out as the block shear strength, which is 236.343 kilonewton. So this is about your strength of the angle section. So now comes to the strength of the bolt calculation. So we know that to calculate the strength of the bolt, we need to calculate design strength in shearing and design strength in bearing. So hence, it is also one type of lap joint. So for that, we can take the NN value as 1 and NS value is 0. So now put all this value in this formula, which is design shearing strength, by which we can got the value as 45.26 kilonewton. So next is your design strength in bearing. So first of all, to calculate the design strength of bearing, we need to calculate the KB value, which is the minimum of all these four values. So by putting E by 3D0, we got the value 0.606. Next is 0.508. Third one is 0.976. And fourth one is your 1. So the minimum of this 4 value is 0.508. So we can put this value in place of KB and calculate the value of design bearing strength. So 2.5 into 0.508 into 20 into 8 into 410 divided by 1.25. We got the value of design bearing strength as 66.65 kilonewton. So now the numbers of bolt is given as 4 numbers of bolt. So we need to multiply the numbers of bolt in both the design bearing strength as well as in design shearing strength. Hence, total strength of the bolt in shearing and bearing we can find out. So now, after multiplying the numbers of bolt, the minimum value of the strength of bolt is coming as 181.04 kilonewton. Hence, the design strength of the angle section is the minimum of strength in angle section and strength in bolt. So, you can see the strength of bolt we got as 181.04 and the strength of the bolt or the strength of the angle section we found out as 236.343. Hence, the design of tensile strength is equal to the minimum of strength in angle and strength in bolt, which is 181.04 kilonewton.